Hello everyone, this is Dr. G. Karthik Reddy working as Associate Professor in the Department of ECE, MLR Institute of Technology, Hyderabad. Today's session topic is cross-correlation function. And this is a overview of the today's session. Okay, significance of cross-correlation, properties of cross-correlation function. What is cross-correlation? Correlation, we discussed in the previous lecture that, identifying the similarity between two process. Cross means two different process. Auto means same process or same signal. Cross means two different process or two different signal. Definition of cross correlation tells that measures it is also one of the mathematical tool, measures the similarity between two different random process, that is x of t and y of t. But x of t and y of t differs with, for example, x of t with time instant t1 and y of t represents a time instant of t1 plus tau, or at some delayed version. It indicates two signals x of t and y of t plus tau. Y of t plus. Next, two random process x of t and y of t. The cross correlation function is defined. This r xy of tau represents this one in terms of White's and stationary. White's and stationary. Then expectation of x of t into y of t plus tau. Here E represents expectation operator, and x of t and y of t plus tau represents two different process. Two different process at two different time instants. And tau represents time difference or time lag between the two different process. Now we will discuss the properties of cross correlation function. Cross correlation function will not satisfy the symmetry property. R xy of tau is not equal to R xy of minus tau. Here it is equal to R yx of tau. Here this is not satisfying the symmetry property. The first property tells that it will not satisfy the symmetry property. Now next, if you want, you can check it. You can apply the formula R xy of tau is equal to expectation of x of t into x of t plus tau. Next, R xy of minus tau is equal to expectation of x of t minus tau. You can check it. Let t minus tau equal to u, then t equal to u plus tau. Then what you are going to get? Expectation of here x of u plus tau, x of u. But here we are using, this is a definition of autocorrelation, R xy. Here y. Here y you are going to get. Then here what you are having y. Now the definition you can check it. Expectation of y of u, x of u plus tau. You can check these two equations. Both the conditions are not same. Then it is not satisfying the symmetry property. Now next, second one, measures the degree of dependence between x of t and y of t plus. It shows the relationship between two different signals at two different time instants. It understands the degree of dependence between two different process or signals. Now next, if x of t equal to y of t, then cross correlation become autocorrelation function. If you want, you can check it. If xy of tau is equal to expectation of x of t into y of t plus tau. When y of t plus tau becomes x of t plus tau, then cross correlation becomes autocorrelation function. Now next property tells that the absolute value of cross correlation function must be less than or equal to their geometric mean at the x of t of autocorrelation, product of x of t into y of t of autocorrelation function at tau equal to 0. At tau equal to 0. This is a definition of one of the important property of cross correlation function. Means the absolute value of the cross correlation function, which is equal to less than or equal to square root of at tau equal to 0. At tau equal to 0 of x of t and y of t. Two different process, x of t and y of t, two different process. The square root of that, okay, product is equal to this one. Okay, these are the properties which we are having in cross correlation function. And here it is not satisfying the periodic property also. It is not satisfying the periodic property in the cross correlation relation. Okay, and now next, okay, cross correlation function, we are having the formula rxy of tau is equal to expectation of x of t into y of t plus tau. If both are uncorrelated to each other, then one more property, this is fifth property, x of t, then expectation of y of t plus tau. And if they are wide sense stationary, if stationary and uncorrelated, then it becomes x bar into y bar. Rxy of tau equal to x bar into y bar. This definition you will get only when x of t and y of t are uncorrelated to each other and independent to each other. Then this format you are going to get. Here in this case we have discussed the symmetric property. Okay, here because it is not symmetric in nature and we already discussed that. Okay, if x of t equal to y of t, cross correlation function becomes autocorrelation function, and the maximum value of the cross correlation function you are going to get whenever you are taking the same signals at tau equal to 0. Product of that, square root it if you apply, then you are going to get, that is the cross correlation magnitude. Cross correlation magnitude we are going to get for that particular signal. Okay, cross correlation you can use, for example, okay, this is the one of the signal and this is the second signal. Okay, this is t instant, this is x of t, this is t, this is y of t. Okay, this is t, you can take for the t plus tau. This instant and this instant are two different time instants. When you are doing the product, then what is the relation between them, we can going to identify by using cross correlation function. Okay, these properties are useful while you are solving the problems related to cross correlation function. Thank you.